Hello, sorry I was having issues with my mic. Hello Daniel, hello Kokzang Chan. We are doing whatever you want to do today. If you have any questions or topics you want to talk about, then we can discuss them. Daniel mentions geometric proof. Here's one for you. Why? There we go. Rectangle. And a triangle. How much area of that rectangle is outside of the triangle? Hello VK. Binomial distribution. That's something I haven't thought about a lot recently. Decision maths, I have very little knowledge of that topic, unfortunately. Sorry, I can't help much with decision. The proof of sine of A plus B, yes. We can go over that. Year 7, you should be able to figure this one out. How much area of this rectangle is outside of this triangle? So maybe if I shade this, that's the triangle. How much area is left over when you, or how much area is outside of the triangle? And then, well, if you think about that, if I change the triangle, if I do this, oops. Binomial distribution. What can I say about binomial distribution? Well, it's when you have what's it called? I'm drawing a blank. The type of probability where you have two outcomes. So you can either have a heads or a tails if you're flipping a coin, or you can win or lose. So they're the types of things you're talking about when you're talking about a binomial distribution. It's in the name, I guess, binomial. meaning 2 outcomes. And I guess the fundamental idea is that as you increase the number of trials, no, that's not right. Oh, that's right. Yeah, the closer the outcomes are to half and half, the more likely that binomial distribution is to be estimated by a normal distribution. So hopefully you know what I mean by a normal distribution. That means that everything is kind of evenly spread out on what we call the bell curve. So the middle value is the most likely at 50%. And then as you get more extreme, the less likely you are to get those values. And let's say you had let's try to think of an example. What's a realistic example? Oh, well, let's say that some chocolate company is running a competition and you've got, 1 in 6 chance of winning a chocolate bar. So the probability of success is 1 in 6. The probability of failure, which we normally label as Q, is 5 out of 6. You're going to have to do more trials for that binomial distribution for it to estimate a normal curve, because the probabilities are further away from 50%. If you're flipping a coin, P equals 0.5 and Q equals 0.5, you should get about an even number of heads and tails for however many throws that you do. So if you do 2 flips, you should, on average, you should get a heads and a tails. So for a coin, the binomial distribution is like a normal distribution. But if the probabilities are further away from 50%, you need to do more and more trials to estimate that with the normal distribution. Cock says, I'm having problems on angles and coordination. Okay, we could talk about that. How could you explain congruence? Like scale factor, volume factor, and how to find congruence. Bridging. Okay, a few topics here. So I'll get to that proof, Joseph, towards the end. Or I might just do a video on it, because it might take a while. Well, it's not that complicated, but it just takes a while to explain. Okay. Oh, and then just to finish off on the binomial distribution, what you learn in A-levels helps you solve those probability problems with 2 outcomes, like how likely is it to get 10 heads in 20 flips and things like that. Although that doesn't really need a binomial distribution, but those types of questions. Angles and coordination. Well, I'm not 100% sure what you mean by coordination, but angles, there's so much to talk about angles. What's this angle on this straight line. How many degrees on that straight line? Have I even drawn an angle? $180, exactly. And then if I say, well, draw a straight line coming off it, you know that these two angles must add up to 180, A and B. And then if you're given an angle for B, let's say B was 120 degrees, you can straight away say A must be 60 degrees. What about angles around a point? You know they must be 360 degrees, right? Angles like on a compass, the total number of degrees in a circle, 360 degrees. Yeah, I'm not really sure where I'm going with this. But yeah, I mean, there's so much you could talk about angles. How many degrees in a triangle? In a two-dimensional triangle, there are 180 degrees. And I guess I won't talk about the other types of triangles because that would just be confusing. Congruence is, you know, identical shapes in every way. I guess they can be rotated or translated, but they cannot be stretched or increased by a scale factor. So if you have two shapes that are not of the same scale factor, they won't be congruent. They'll be similar. That's a different thing. Similarity is different to congruence. 360 degree triangle. Yeah, well, you could. No. How do you find it? Oh, for two triangles. Okay, so there are 3 or 4. Let's see if I can remember what they are. Okay, so if you have two congruent triangles, there are some tests you can do. So firstly, if you have two angles the same and a side the same, in between, then they're congruent. That's called angle side angle. Or, oops, and if I mess any of these up, then please correct me. Or you could have two sides the same and an angle between them the same. That's side angle side. You can also have the special case where you have a right angle triangle and for that you only need the hypotenuse and the leg to be the same. Okay, so that's I refer to it as the hypotenuse leg rule for congruence. And there's one other one I think I'm missing. Side angle side, angle side angle. Is there one for, so if you have two sides and then an angle the same. Yes, that would be also congruent, right? Side, side, angle? Or would it be? No, because that could be any length. Hmm. Oh, it's just angle, angle, angle. I'm forgetting. So if you have all of the... No, that's wrong. Oh, it's angle, angle side. Is that right? Oh, side, side, side. Of course. Of course. No. But yeah, side, side, side. This is wrong. That's the other one. If all the sides are the same length, then you have congruence. There we go. Abdullah, maths tutoring, with the answers again, as always. RHS, which is the right angle triangle, so right hypotenuse side, 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 sine angle side, and angle side angle. So they are the 4 situations where you can have congruence. So if you can remember these acronyms and what they stand for, then you can remember the situations of congruence. Area of a sphere. That is the the 4 times something. 4 on 3 pi r cubed. Is that right? The area of a sphere. Four on 3 pi r cubed. And also forget why. So it has something to do with the area of a circle. So the area of a circle is pi r squared. Four and 3 pi r cubed, volume of a sphere. Right, I remembered somehow, but I cannot. No, I don't think I can give you a derivation of that formula at the moment. Sorry. Any other questions? Coxang says, my mum's telling me to sleep. Alrighty. Gotta get a good night's sleep before your test. Oh, the surface area. That's right. The surface area. So, surface area is 4 pi r squared. The volume is 4 on 3 pi r cubed. And there's some relationship there. I know you can do it with calculus. I'm not sure if there's another way to do it. Vector proof. I mean, vector proof. I probably... No, I'm not going to be able to think of a question, but we can talk about vectors in GCSEs. Or are you talking about GCSEs or A-levels? A Kahoot. I was waiting for Sabalashan to come because he asked a question the other day that I completely got wrong. He asked for a... I might as well go through it now if there are no other... Oh, Harsh. Harsh, what was your question? Can you prove it with geometry? Trigonometry. Congruence with trigonometry? Hi Arvind. Oh, at the top. Oh, okay, I'll scroll back up. I'm in year 11 and about to be in 6th form. I've completed all the A-level maths curriculum. How much of an advantage will it give me? A huge advantage, I would say. Oh, sorry, at the top. Sorry. Oh, what is the difference between core and pure maths? Is that the one? Well, sorry. Well, I'll just answer them both. Core and pure maths are basically the same things. The new name for core maths is pure maths. And, well, yeah, the other one, if you've done the A-level maths curriculum already, and you haven't started 6th form yet, amazing. You'll be doing great. Alright, so this is the question that I completely got wrong. Hey Sabindra. Solve graphically these two. I was trying to plot out the graph of the quadratic for some reason. I don't know why. I tried to find the vertex. All you need to do with these types of questions is get a table of values. So create a table of values for this equation, a table of values for this equation, and then plot them out, and you get an approximate solution. So I don't know why I blanked on this, but it happens. And the nice thing about YouTube is you're all very forgiving with my horrible mistakes. Okay. So I might go from -3 to 3. That should be enough. So let's just do, I don't know, graph 1 and graph 2. Well, that's kind of confusing. Let's say Q for quadratic and L for the line. How do you do lives? Apparently it says I can do a live unless I have a certain number of subscribers. Really? I did not know that. As far as I am aware, I thought anybody could live stream, but I'm not sure. Sorry, I can't help with that. So I guess I'm sure you've obviously gone to the studio and pressed live. and it just, or it doesn't have the button. The solution is where the lines intersect. Yes, so for this particular question, it was asking to solve graphically, and I'm kind of correcting a mistake that I was doing earlier. So plugging these values in for x, you'll get some solutions for to plot out these graphs. So 6x squared, 6 times 9, 54, take 9, 45, take 7, 37, 38. Okay. 54, take 9, 45, 38. Plug in -2 to this one here. -2 squared is +4, so 6 times 4 is 24. Take 6 is 18, take 7 is 11. Plugging -1 into this quadratic, 6 times 1 is 6, take 3. 3 times -1 is -3. So 6 take 3 is 3, take 7 is -4. 0 will be -7. 1 will be 6 plus 3, take 7, which is 2. Plugging 2 in, we will get 24 plus 6, which is 30, take 7, 23. And then 3, 6 times 9 again is 54, but now we add 9 because we've got 3 times +3. 3 times +3 is 9. 54 plus 9 is 63. Take 7 is 56. Okay. Wait. 54 plus... Yeah. 54 plus 2, right? Okay. Then for the straight line, the y equals 2x plus 8. Plugging these in. -6 plus 8 is 2. -4 plus 8 is 4. And then we're going up by 2's. So 6, 8. Oh, sorry. Yeah, sorry. A straight line will always have that constant scale for their values of y. Use Desmos, yes. You could do that, or you could just try to do it manually, which is also fun. But I mean, I'm guessing the idea of the question was to test your ability to sketch this out. Okay, so where are they going to intersect? Somewhere in here, right? Anyways, so we need to go up to, let's go up to 40 somehow on the y-axis. So 40, 30, 20, 10. This is not, the scales are not going to be consistent. So the scale on the x-axis is going to be slightly different. So 1, 2, 3. And the same scale down here. Ah, yeah, why is that? This should be, something's changed with my settings. That's strange. I don't know. Okay, anyways. Something changed with how I had this set up. I don't know why. Actually. There we go. Alright. Okay, so then let's plot out the because I usually have that open, that's why. Let's plot out the graphs now. So negative 338 be up here somewhere. Negative 211 be down here. Negative 1, negative 4 be about here. 0, negative 7 about here. 1, 2. Yeah, 1, 2 about here. 223 and 356. Oh, way up there. Okay, so I didn't quite get that one on the graph. But you can see the general shape of the quadratic. And the vertex is somewhere close to the y-axis, I seem to remember from my previous working out. Okay, alright, this is not a good drawing, but I'm going to cheat a little bit and draw a straight line there. Okay, wow, that's horrible. That is the graph of y equals 6x squared plus 3x take 7. Let's use a different color. Can I do live every so often, like one time a week? I am trying to, actually. I'm trying to do them more consistently. Yesterday I was meant to live stream, but things happen as they do. Could you please explain to me using ratios to find coordinates in a point? Oh, you mean the ratio of x to y? Yeah, we can talk about that. So anyways, I'm plotting out this straight line. Negative 3, 2. Well, I just need 2 points really, and then I can draw the straight line. But well, let's try to be a bit more accurate. So negative 2, 4. Negative 1, 6. 0, 8. And so on. Okay, so the straight line is kind of going to look like that. And the solution will be where they intersect. Alright, so on this rough diagram, I have an estimate of a solution. Now, if you're actually doing this, you would use graph paper. You would try to get it as accurate as possible. You could still use different scales, but the fact that you would have graph paper would mean that these scales would be exact. Like you'd have a certain number of squares, certain number of units between each number, so it would be much more precise with graph paper. The fact I'm not using graph paper is just because I haven't got it set up that way. But then you'd get a pretty good estimate of the solution. So on this rough diagram, I've got about, I don't know, what could you say? Maybe just less than 1.5, maybe 1.4, and then y, what would y be? Well, it's less than 12. One, 2, 23. Maybe, well, let's just say 11. But it could, I'm not saying it is 11, but that's just my estimate. So graphically, considering you'd be using graph paper for this, we get an estimate for the solution of y approximately equal to 11 and x approximately equal to 1.4. So now let's go ahead and see what the actual solutions are. Okay, bye Harsh. Thanks for tuning in. So we've got y equals 6x 6x squared plus 3x take 7, and y equals 2x plus 8. And I'm hoping I'm not way off here, but let's see. Hello Dexter. Do you like the TV show Dexter? Or actually probably oh, look at that. Hey, come on. Oh, I forgot the other solution as well. Oops. I forgot the other solution. Of course, there's two solutions. But 11 and 1.4, that's pretty good for my rough graph. So what would the solution be over here? About 1.6. So I should have written this differently. So we should say the solutions are 1.4, what I had originally, even though it's 1.5. These are estimates. And what's that about? Negative 1.6, negative 1.6, and could we say 6 maybe? 6. Okay. So what were they again? So negative 5 on 3 and 14 on 3. What's that? That is 4 and 2/3. Okay, a little bit off there. But you get the idea. That's how you should be. That's how you should be solving these types of questions. And the reason I did that, the reason I went through this one is because I made a mess of it the other day. Okay. How do I differentiate into and integrate sine squared x and cosine squared x? Not my mouse, although it kind of looks like I'm trying to use my mouse because it's so messy, but I do have a tablet, a graphics tablet, just a cheap £20 one. Only for x? So this is how the question was stated: y equals this and y equals this. So you have the two variables. So I think you do need the solutions for y as well. depending on what the question asked. If it just said find the solutions for x, then of course you'd be then just give those. So differentiate, integrate sine squared and cosine squared x. So let's say, let's just do this. The derivative of sine squared x, I always forget, is it negative, cosine, or just cosine? I don't know about the infinite power tower. Check out number file or 3 blue, 1 brown for that one. Oh no, who was it? Who did that? Well, a few YouTubers have done that one. Or is it black pen, red pen? I can't remember. Sine is positive, right? And the derivative of cosine is negative. Well, we could just use the graphs. Okay, so to remember which one is which, let's think about... no, but that's for sine x, not sine squared x. Oh, but it's the same. Yeah. Mm. So I'm just trying to remember. I don't want to have to do this by first principles. I'm trying to remember why The derivative of cosine is negative sine. Oh no. Okay, as always, something comes up and I have to go. Hopefully a live stream next Wednesday is the next day that I can do this. Thanks for tuning in, as always. A lot of fun. I really enjoy doing these live streams. It's really nice that you all come along and have a chat. I mean, if you weren't here, then I wouldn't be doing it, so it's very much appreciated. So in terms of how to do a live stream, all that I do is go onto YouTube Studio, and there's a button at the top that says create. I think it says, hang on. Yeah, it says create or something, and you click on that and there's an option to live stream. I don't know any more than that really. If you're asking about like what program you need, you also need a streaming program on your computer. You need a program called OBS, which actually encodes the video. So you need OBS as well. Ah, 1,000. Says I want to help you with it. Well, guys, we have to get Abdallah to 1,000 subscribers. Also, oh, one more thing. If there's anyone still here, there's a channel called Potion Low, Daily Challenge with Potion Low. Every night at 11 p.m. Sorry, that's wrong. Or one of them was 11, but usually I think they're at 8 p.m. About 8 p.m. London time. Tune into that. I'll be in that one. I'm usually joining in on the live streams, like just in the chat. So if you want to go along and check out his live stream, I'll be there as well. He's a professor of mathematics. He's really entertaining. It's called the Daily Challenge with Potion Low. So I believe if you just go to YouTube and type Daily Challenge, it should come up. It's really interesting. If you're here, then I'm sure that you get a lot out of it. Alrighty, see you next week. Bye for now.